This is project 8. We're going to download inertial measurement unit or IMU data from Arduino to Raspberry Pi and then from Raspberry Pi to our host. So the requirements are that we're going to connect the IMU sensor to the Arduino and collect the yaw, pitch, and roll data. We're going to use free RTOS to do this and structure it as a task. We're going to send this IMU data from the Arduino to the Raspberry Pi using serial over USB, so we're going to directly connect those two. And then we're going to send the IMU data from the Raspberry Pi to our host over Wi-Fi. Then we'll mount the Arduino and the Raspberry Pi on our quadcopter. We'll capture the roll, pitch, and yaw data as we fly, and then we'll display this data on our host as the quadcopter flies. For the hardware, we're going to need the quadcopter as we built it in Project 4. We want an Adafruit BNO055 absolute orientation sensor. The Arduino, I have a Mega 2560. Then we'll need a serial to USB cable, the Raspberry Pi in its case installed as last time, a portable charger to power the Raspberry Pi, a USB to USB-C cable, and then of course our laptop. I'll show you a video that does this closer up, but here's a photo. So let's look at the connections we have here. This VIN pin I've got connected to 3.3 volt power. Ground is obviously connected to ground. And then since I have a Mega 2560, excuse me, I've got my SDA pin connected to the corresponding pin 20, which is SDA, and then the same SCL connecting to pin 21. And then the Arduino is being powered by the Raspberry Pi as well as this serial data. That's just with my USB cable. I noticed when this is plugged into the laptop, the free RTOS script doesn't run very well, so you need to use this other power module to connect the Arduino to power separately from the serial connection. And then we're attaching this to the quadcopter, and hopefully it won't get damaged or fall off while we're flying. As far as software goes, so the Raspberry Pi is all set up based on Module 6. One of the easiest things to do is to download the Arduino IDE onto the Raspberry Pi itself. And so this was pretty straightforward. You just go to the Arduino website. I am running 32-bit ARM on my Raspberry Pi, so you need to figure out what your Raspberry Pi is running, and then you download the compatible software. I also saw that you could do apt-get install Arduino, but then some people were saying that that is a different version, so just look into what version you want before you do this, but that might be a little bit more efficient. Then the next thing you want to do is you want to be able to use free RTOS on the Arduino. This is as easy as just installing a library, the free RTOS library. And then you want to include the library, and that's just going to be to #include Arduino free RTOS in your source code, and I'll walk you through that in a second. Note that if you're not using the free RTOS syntax, but you have this header included, you will get crazy output and it won't run correctly. So if you're going to include the header, you need to be using free RTOS. It took me a minute to figure out what was going wrong. You're also going to need to install libraries to use the Adafruit sensor. It's going to need 2 libraries, the Adafruit Unified Sensor library and this Adafruit BNO055 library. And then we'll walk through the sketch that we upload to the Arduino now. So we're including these libraries that we installed. We're going to initialize our sensor, and then since we're using RTOS just for practice, this is really only one task. I'm calling this task IMU. In the setup, we're just going to open up a serial connection and print out our orientation sensor data, and then we're going to create our task based on the free RTOS syntax. We don't do anything in the loop. All the work happens in the task now. So we're not actually using these parameters. This starts up our BNO sensor. We're going to delay for a second, and then in this never-ending loop, what we're going to do is get our sensor event, and then it's just as easy as printing the X, Y, and Z data from that sensor event, and this will print repeatedly with 5 microseconds in between. So very straightforward. We upload this to our Arduino. I'll show you what this looks like on the Pi now. We've got our sketch uploaded already on the board. So if I look at my serial monitor, this should be running. We can pull this over. Yep. So this yaw, pitch, and roll data is coming in from the sensor. It's going to calibrate for a while, but once it does so, I'll show you a video of how I move the sensor and how that changes these data points. So we've got the IMU data streaming in on the Pi, and here we have the Arduino, which is connected to the Raspberry Pi. I don't have it connected to the drone yet because I want to show you so that we can see accurately. So I'm going to try to put this in the same view. Okay, so I'm going to tilt this, sort of turn it like this first, and that we should see the yaw changing as I turn that. So there we go, and that's what we're seeing. Great. And then as I go up and down and change it in this direction, we should see the pitch changing, which it's doing. There we go. And then when I tilt side to side, we should see the roll changing. And we do. So it looks like that IMU data is coming in well, which is great. So the next thing to do, now we've got the data sending over serial from the Arduino to the Pi, and now we want to send the data from the Pi to the laptop over Wi-Fi. So I'm going to set up a TCP client and server. So I'm going to run the server on my Raspberry Pi. I'm just going to send this IMU data to the client, which will be running on my laptop. So I have, I'll open these both up here, but on the Arduino, like this, so we can see. So we're going to close out this monitor. On the Raspberry Pi, I'm going to run my, we'll look at it first. This is going to send the IMU data. So basically, I'm just binding to port 5005, and I'm taking in the data from the serial port, and then I'm reading it and sending it over the connection. So it's very straightforward. So I'll run that on the Raspberry Pi, and then over here on my laptop, this is where I have the client running. I'm going to connect to, this is the IP of my Raspberry Pi and the port I'm connecting to, and then I'm just going to receive data continuously. So when I run this, we should see this streaming now. Great. So this is pulling in the yaw, pitch, and roll data from Raspberry Pi to my laptop. And when I tilt the sensor, you can see this data changing. So everything's working as intended. Next, we'll do a video showing this as the quadcopter flies.